Continuing with our element condition, the next step would be to click on the measurement order. This brings up a window that shows you five different channels, the 5 different WDS spectrometers, and the crystals in those spectrometers that will analyze the elements of interest. The crystals, normally like TAP analyzes the light elements, and LIF normally goes for the heavier elements. If you want a nifty way of finding out which crystal analyzes which elements, you can go over to the offline menu, hit utility, and the L value table. And this is really cool. If you go over to option, then hit crystal, you get another box here on the right. And here, these are the crystals loaded on our spectrometers. This is the LIF. So if you click on LIF, in pink it'll show you the K lines that it'll detect for the different elements. So LIF, like I said, kind of like the heavier elements. LIFH, PETJ, aluminum to cobalt. PETH, TAP, the lighter ones, oxygen all the way to sulfur. And LDE and LDE2H are the really light elements, if you're interested in those. Okay. So let's close this. Alright, so this panel shows the element arrangement on each spectrometer, and each element can be moved to different spectrometers. Silicon we're analyzing with the TAP in channel 1, and also in channel 3 with the PETJ. Now we're doing this just in case when you analyze your unknown olivine sample, you might be analyzing silica in one of these 2 channels, but we'll have standard data to compare it to. That's why we choose multiple elements. Okay. Right here, this button chooses the information given next to the element. You can choose crystal or position. Now what we like to do with position is arrange the elements either ascending or descending from greater to smaller positional value, or larger to smaller, just so it decreases the instrument analyzation time. So it won't have to move the crystals into different positions back and forth. Rather it would go sequentially. So let's go back. These are all ordered already. So let's go back to crystal. And you can choose to add elements. Silica, if you'd like to analyze it in channel 5, you can just kind of click it and move it over here, and it's a PETH if you're interested in doing that. We can add silica to channel 5. If you go back and add it again under the element option. Okay, and the only thing I wanted to mention that users really need to know is the PET crystal in channel 2 doesn't work. That's one thing we just have to remember, is don't use, say, like PET silicon. You can move it over to channel 2. It won't work. That crystal's broken and needs to be fixed. Other than that, each spectrometer has 2 crystals, and this is kind of like a suggested arrangement of analysis for standardization of olivine. Okay. Now when you do your quantitative analysis, you're not going to run nickel 3 different times on 3 different spectrometers and crystals, or silicon twice or magnesium twice. You wouldn't do that. You would just choose one. Okay, the next thing you want to do is element condition. Okay, this is where the data for each standard is stored. All right, we'll pull this up. And this is where you also check for peak overlap. This information here, it's kind of like is the WDS element condition here. This is our calibration. We do this on our own, so you don't have to worry about that. The only thing you may have to worry about are the positions of where it starts measuring the principal peak of each element. Now, if you want to check for peak overlap, you can click this button here. And in this case, there are some peak overlaps with the silica K alpha energy line and iron K beta 5 energy line. Now that's a fourth order energy line, so it's not that important. If we have peak interference with a first order energy line, that's a problem. And you can adjust the position of where you define the peak, which can help get rid of peak overlap. But that's something that if you don't feel comfortable playing around with it, you can ask the FCAM staff to fix it for you. So in this case, these are all 4 and 5th order interferences, which are really small and elements of kind of a this isn't too bad. So we'll accept that, and you can hit OK.